Hello, this is Stef. Welcome back to my channel, and today we're going to see ChatGPT. ChatGPT is a chat box driven by artificial intelligence, developed by OpenAI. So OpenAI is the same one that developed DALL. So if you heard of it, you can use it another time, or maybe something else like Stable Diffusion, but that's a topic for another video. Let's get back with ChatGPT. Let's try and interrogate ChatGPT. Let's have a chat to see if what is the thing that comes out of images, videos, video compression, and why not FFmpeg or something else. Let's see. And so for the moment, browser behind me. So let's ready, hang on. I would like to thank you very much for your affection, and I reached 100 subscribers, so I'm really happy. Thank you very much. If you didn't, please like, share, and subscribe. Hit the notification bell so you'll be notified about the next video I'll be releasing, about the multimedia videos and much more. For the moment, we are ready, and let's get started. Okay, this is what appears as soon as you log in. You got to log in with the OpenAI account. So if you didn't do it, you can sign up. And here, this is what appears. So you have the chat here. Let's ask the first question. So, what is digital video? Let's see. Digital video refers to video that is stored in digital format. This is in contrast to analog video, which is stored in a physical format such as on a VHS tape. Digital video is often of higher quality than analog video and can be more easily edited and manipulated using computers. It is also typically easier to store and share digital video, as it can be transferred over the internet or stored on digital media such as a hard drive or DVD. Cool, so convincing. Let's go on. So what is video compression? What is an image first? Sorry. What is an image? An image is a representation of something, such as a person, place, or thing that can be seen by the human eye. An image can be a photograph, a drawing, a painting, or any other visual representation of something. Images are often used to convey information or to create a particular effect or impression. For example, an image of a beautiful landscape can be used to evoke a feeling of peace and tranquility, while an image of a scary monster can be used to create fear in the viewer. Images can be created using a variety of methods, including photography, painting, and drawing. Okay. So, what is image compression then? Let's see what... Image compression is the process of reducing the file size of an image without significantly affecting the quality of the image. It is often done to make it easier to store and share images, as smaller file sizes take up less space and can be transferred more quickly over the internet. There are several different methods of image compression, including lossless and lossy compression. Lossless compression reduces the file size of an image without losing any of the original data, while lossy compression sacrifices some of the original data in order to achieve a greater level compression. In general, lossy compression is more effective at reducing the file size of an image, but can result in a loss of quality. So it's technically convincing. I would like to go on with this thing. So what are the image lossy compression algorithms? Let's see. There are several different algorithms that can be used for lossy image compression. Some include JPEG, JPEG 2000, and WebP. JPEG, Joint Photographic Experts Group, is a popular lossy image compression algorithm that is widely used for compression photograph and other continuous. Okay, no, it works by dividing the image into small blocks and removing redundant information from each block, which reduces the file size of the image. JPEG 2000 is a newer lossy image compression algorithm that offers improved compression efficiency and a better image quality than JPEG. It uses a different approach to compression, dividing the image into tiny regions. Okay, we can go on, and it seems convincing. So the explanations are okay. Can you tell me? Let's see if we ask about the JPEG. Can you tell me something more about the JPEG algorithm? Okay, this is the thing that said before. It was first developed in the early 90s and has since become the most widely used image compression standard in the world. JPEG works by dividing the image into small blocks and removing redundant information from each block, which reduces the file size of the image. The process is known as discrete cosine transform. Fine. And it allows JPEG to achieve a high-level compression while maintaining good image quality. One of the key advantages of JPEG is that it is a lossy compression algorithm. It says this means that the file size of a JPEG images will be smaller than the original, but the image may not be an exact replica of the original. This can be advantageous in some cases. It allows the image to be more easily stored and shared without taking up a lot of space. JPEG is used in a wide range of applications, including digital cameras, web browsers. So, gets a bit more technical. It is not expected to be a bit more technical, but maybe it's because the question is not asked accurately. But I think that we can go on with this format. Let's see. Tell me about DCT. So the cosine image compression, discrete cosine transform, is a mathematical operation that is used to remove redundant information from an image. DCT is used by the JPEG compression algorithm to divide the image into small blocks and removing redundant data from each block. Yes, so the DCT doesn't by itself divide the blocks, but it does remove redundant data from each block, which reduces the size of the image. DCT is a type of Fourier transform, which is a mathematical operation that is used to represent a function or signal as a somewhat simpler trigonometric function. In the case of DCT, the function being transformed is the intensity of the pixel in an image. The DCT operation decomposes the image into a set of coefficients, which represent the relative importance of different spatial frequencies in the image. The coefficients that represent low-frequency spatial information, such as the overall brightness and color of the image, are preserved, while the coefficients that represent high-frequency spatial information, such as fine details and texture, are discarded or compressed. This allows the JPEG algorithm to achieve a high level of compression while maintaining image quality. Okay, so now we are in the words world. Now let's go on with, let's see if we can publish some code, can get some code. Can you get some code, some Python code to calculate a DCT of a block of pixels? Sure, he's okay. Good. Okay, creates random values. DCT 0. And okay. Well, that's nice. In fact, so up to here. Okay, this is simple because it takes every pixel in the block and it calculates the DCT. So if you, this is a translation of the formula that we can ask him directly. What is the formula for the DCT? Okay, so you see the sum of sum. In fact, there are two sums included. DCT. So, So sum of the block and the coordinate. And then there is the formula. So cosine of u and v. If you take this is the same that you find on Wikipedia, for example. So if you take the Wikipedia page about, let's say, DCT, see what comes out. And you go down, no, maybe, yes, so here. The one that is used in the JPEG should be the DCT2. But if we take the JPEG directly, let's go with the JPEG given by Wikipedia. If you go down here, there's the thing about where is it? It's here at the top. There should be the formula of the DCT. Here we go. Take the double screen here, right here. You can see that the formula is the same. So you have a sum of sum. In fact, there are two sums. Block cosine 2x plus 1 u pi divided by 2 times n. In fact, here the block is of 8 by 8, so 2 times n is okay. And here the cosine to y plus 1 times v times pi divided by 2. So correct. So I'm really impressed by what it can reach. Let's push it a bit further. Let's see. Tell me about JPEG 2000. Lossy image compression algorithm that was developed as a successor to the popular JPEG. JPEG 2000 offers several advantages over JPEG, including improved compression efficiency and better image quality. It uses a different approach to compression, dividing the image into tiny regions. Through improved compression capabilities, JPEG 2000 also offers several other features that make it attractive for use in a wide range of applications. This includes support for high dynamic range images. Let's ask, how does JPEG 2000 work? Okay, so it uses advanced mathematical techniques to compress the data in an image. Unlike the original JPEG algorithm, which divides the image into small blocks and applies the discrete cosine transform to each block, JPEG 2000 uses a different approach called the wavelength transform. It's correct. Then, wavelength transform, the image is first divided into a series of increasingly fine-grained scales or levels. Each scale is then further divided into a grid of small regions called code blocks. The wavelength transform is then applied to each code block, resulting in a set of coefficients that represent the spatial frequencies in the image. The coefficients generated by the wavelength transform are then quantized and entropy coded, which removes redundant information and further reduces the file size of the image. Finally, the quantized coefficients are organized into a hierarchical structure, which allows for efficient progressive decoding of the image. This means that the image can be decoded and displayed at different levels of resolution depending on the needs of the application. Overall, JPEG 2000 is a complex algorithm that uses a combination of wavelength transform, quantization, and recoding to achieve high levels of compression while maintaining good image quality. It offers several advantages over the original JPEG algorithm, including improved compression. It's the thing that before. Okay, so it matters on how do you ask the questions. So here you got to ask the right questions to get the right information out. So now let's see what can we do with FFmpeg. So tell me about FFmpeg. Like so brutal. FFmpeg is a free and open source software project that provides a complete cross-platform solution for recording, converting, and streaming audio and video. It is written in the C programming language, and it is widely used for recording, converting, and streaming audio and video on the internet. They included a collection of libraries and programs for handling various media files, popularly the V-codec, which provides a wide range of codecs, including decoders for audio and video compression. To convert, okay. I think that this is the definition. Can you give me a FFmpeg command, an example command, I can use to convert a video from one format to another. So -I, CV, okay. CRF23. So here it takes the constant rate factor at 23, which is good. It's in the lower limit of decency. So if you want to have a good quality video, and it takes AAC as audio codec and H.264 as video codec with 128 kilobit per second here, and then in outputs as MKV. Cool. And explains everything. Like it. Nice. Okay, now let's see. Let's get somehow deeper and let's ask about something more complex. FFmpeg, let's say complex filter. Filter complex. It's thinking, and the reply. The filter complex option in FFmpeg is used to specify a sequence of filter graphs, which are groups of media filters that can be used to transform and manipulate audio and video streams. This option is typically used in advanced FFmpeg commands to apply multiple filter graphs to the input media, and blah 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 blah. Here's an example. I use a filter complex. Okay, so it takes the first video, makes an H stack, and then it outputs the video. Each stack makes the videos like this. If you remember from the filter complex, this is something that we've done with something a bit more complex than this. If you remember the tiling video, I put the card here on top. Yeah, seems fine. Let's see how to let's say crossfade videos with FFmpeg. Let's say 2 videos. Let's keep it simpler. Okay. To crossfade 2 videos, you can use the blend filter. Okay. Good. So it takes a filter that I don't know, the blend. Let's see, what does it do? FFmpeg blend. Let's see the wiki. Okay, it makes the blending in this way. Understood. Let me take the filter documentation. Blend. Okay, blend 2 video frames into each other. The blend filter takes 2 input streams and output 1 stream. First is the top layer, second is the bottom layer. Okay. Blend opacity. Apply transition from bottom layer to top layer in first 10 seconds. Okay, it seems like that this is the formula. Let me have a look. Yes. Let's try it. Okay, here we go. We have the two videos, so the two input videos, input 1 and input 2, so renamed as the common ones. Let's play them just to show you how they look like. So this is the first input. We have an aerial view of a city, and then we got the other with a shore. So two beautiful videos. I've trimmed them and resized them. So let's take the command directly from here, and I copy pasted as it is, and we should create an output file. Let's see how is the result. And yeah, the video is okay. Let's play it. This is the first video. That's it. Play again. There is something wrong here. I think it needs a bit more refining. By the way, let's go on. Let's see how to rotate a video in FFmpeg. Let's have a look. Too many requests. Okay, so it seems like I tried too much in the last session, and in the meanwhile I couldn't get back, but now here we are back, and let's see how to rotate a video in FFmpeg. Let's see. To rotate a video in FFmpeg, you can use the transpose video filter. Here's the syntax. I wouldn't use it, but anyway, there is the rotate filter. So there's 0, 1, 2, 3. So for example, to rotate a video 90 degrees, you would like to use the following command. Okay. Okay, but I want to rotate a video, let's say 60 degrees. So how to rotate a video by 60 degrees in FFmpeg. In fact, there is the rotate video transpose filter, only allows to rotate by 90 degrees. So something that we discovered today. Cool. I never used officially the transpose. We use the rotate with 90 degrees. And the flags parameter is optional and controls how the video is rotated and resized. The possible values of flags are bilinear, bicubic, neighbor, area, length. So all the parameters, all the interpolation parameters. Okay. Good. Good. Interpolation methods such as a bicubic. Got to use the bicubic. Cool. Satisfied. 100%. Now let's suppose we want how to let's say something that we said how to stream map using FFmpeg. Let's see. How to stream map? You can use the JIP. Wow, what is a GIP? Nice. So it's a useful tool to discover new things. Cool. Like that. So a node SRC to generate a silent audio stream, which is then combined with a GeoIP filter to display the location of IP addresses on a map. The location option specify the location field. No, we got to use this. Here we go. We take the command already copied. Let's paste it. Let's see. The input format GeoIP is not recognized. Okay, that I put also the RTMP server, whatever it is. But we can put a file here. Nice. I'd like to have more information about GeoIP. Let's take it and use GeoIP. Tag issue. Okay. Let's see another thing like how to generate a test video using FFmpeg. We made a video, put the card here on top. How to generate a test video using FFmpeg. Okay. To generate a test video with FFmpeg. Let's see. Too many requests, please slow down. Okay, let's start over. Let's see if we can. How to generate a test video using FFmpeg. FFmpeg is a powerful command line tool for manipulating audio and video files. To generate a test video, you can use the test SRC, the one that we saw in the video. FFmpeg -f LFI. Good. Nice. Nice. So that's the one that we saw in the dedicated video. Pretty corresponding. And let's have a look at this. So copy code, paste here, and well, let's take the right folder. No, this folder. Okay, and let's paste the video. We didn't see it's going definedly. I got to press Q to finish, and here we have the test video. And here we have our test video. After play, test. And here we go with our test video. Cool. Now let's see how to stream a video using FFmpeg. How to stream a video using FFmpeg. Okay, streaming server. There are many options for streaming servers. Being free open source solution like Red 5 and then GIX. Okay. Okay. It's nice. Tells you pretty much everything. So the -RE and then the flag. Cool. Now let's stop with FFmpeg. Let's go with MPlayer. So another tool that is derived from FFmpeg. Let's see. Tell me about the MPlayer. So MPlayer, okay, this is the player. There is a Mencoder, there is the encoder. I like to convert videos. Okay, Its ability to play a wide range of media formats without the need of external codecs. It includes support for a variety of audio and video codecs, as well as support for subtitle formats and streaming protocols. Ooh, that's nice. Okay, let's see how to use Mencoder to play a proprietary video using the DALL. Let's see if it gives a proper answer. Okay, now it is describing what is Mencoder. First, need to obtain the DLL file and make sure it is accessible to Mencoder. This may require copying the DLL file to the directory where Mencoder is installed, or adding the codec or the directory containing the DLL file in your path. Once you have the DLL file set up, you can use the OAC and OVC options with the Mencoder to specify the audio and video codecs respectively. You can use the DLL option to specify the path of the DLL that you want to use. Here's an example. Nice. Like it. Okay, nice. How to use FFmpeg. Let's get back to FFmpeg because this is a question that we didn't ask before. How to use FFmpeg to use a proprietary DLL with a video. Okay, description about the FFmpeg. Okay, the same thing said before. Minus codec. Codec, minus DLL. I don't know it exists. Let's see. Okay, here it doesn't seem promising. Can include the DLL. No, Windows DLL are not portable, bloated, and often slow. Moreover, FFmpeg strives to support our codecs natively. A DLL loader is not conducive to that goal. Okay. Now I also have suspicion about the GeoIP before. So I think that it's going to reply with the amount of texts that contain both of the references. So in this case, there might be some issues while dealing with text dealing more or less the same thing, but one is not including the other. Let's see. Maybe that's a mistake of mine, but another mistake that I see, -O. Never seen -O on FFmpeg. -O, it is something related to, for example, MPlayer, something that we saw before. This accept -O as flag. Here it doesn't accept -O, so there's a mistake. Okay, we played a little bit with ChatGPT, and I hope you liked it. I personally liked it. I'm quite impressed by the amount of options, but they are still to verify. So it's not a tool that you need to take and give for granted everything that it says, because sometimes, depending on the context, you can say some mistakes. So for the moment, you can leave things like so. Take the output, verify, and then I'm personally impressed. We know that it's in an early stage, but I'm pretty impressed by this stage. I'm waiting for more progress on this. For the moment, if you like this video, thank you very much. So please like, share, and subscribe, and hit the notification bell, just in case you would like to see the other videos I'll be releasing. For the moment, thank you so much. Follow my social media, TikTok and Instagram. Where I'll be posting something, would like to be more organic. So if you have some suggestions on what you would like to see, please leave a comment. Down below. And also leave a message on either personally or thing. So I have some ideas from some of you. Thank you very much for this. and thank you very much for following. For the moment, thank you so much, and see you next time for some other videos regarding FFmpeg, but also much more. Bye, ciao, ciao.